Hey everyone, I just wanted to make a quick tutorial going over how to build your lecture work assignment, the trimmer head. This is a really good part because it utilizes your global variables and equations. So we're not making three parts, we're only making one, and then we're just changing that variable L to create the three different sizes. So you would only submit one part file. This is going to help you for your upcoming exam. So we just want to create this trimmer head. I'm going to go ahead and just start with my right plane because I'm going to sketch that side profile. So select that right plane and bring it normal to you. Make sure that your part document window is in the right units, which we need to build this in inches. Next, you're going to want to add in your global variables. So go over to Tools on your toolbar, go down to Equations, and let's start with our global variables. So to begin with, I'm just going to list L. Then tab over. Remember, your global variables automatically will come up with the quotations. SOLIDWORKS does this, so you don't need to add it in. So you just need to choose one value to design your L or your beginning part 2. So I'm going to choose the largest length. So L is going to be 4.96 to begin with. Then hit enter. Next, I'm going to add in my t value. I'm adding this as a variable because it is a fixed value. So it's given to me as 0.12. And last, I'm going to add in my s value. Now this one is a variable space, so we need to solve for s. So if you're looking just at this quickly, it may look like it's hard to solve for s, but this really is a simple equation. So we take our overall length, we have our overall length equals, now we have 9 t slots, so 9t plus 8 s's. So now we just solve for s. So basic algebra, we can have 8s equals L minus 9t, which gives us s equals L minus 9 multiplied by t, all divided by 8. So what looked like something crazy really is not. I'm just going to copy and paste this just to save myself some time. So this is our equation. So we're going to add in our equation here. So you do need to remember that if you are utilizing global variables, you need to select them. So both of these letters need to be the same as what I've already listed. So both of mine are uppercase, so make sure yours are uppercase. And then I need to add in that multiple by 9. And hit enter. If you hit enter and everything works out, then you're great. If you have an error, make sure you check your parentheses. In math, we've always been taught to add in parentheses whenever we want to multiply something first before doing the rest of our equation. In SOLIDWORKS, we do not need to add in extra parentheses around the t and the 9. We just add it over the whole function that's then going to be divided by 8. So once you list your L value, your fixed t value, and then your s equation, go ahead and hit OK. Now select your right plane and bring it normal to you. We're just going to sketch that side sketch. So go to your Sketch tab, open a new sketch, select your line segment. I'm going to start with this vertical line. So remember, sketch from your origin, go straight up. We have about an angle here, another vertical line, horizontal line, a vertical line, kind of an angle, and then we connect back and hit OK. I'm going to bring this endpoint down a little bit just because I know it comes a little lower. Now let's dimension it. So go into your Smart Dimension, and I am just going to start at the bottom. So this line segment is 0.12. My overall height on this line segment is not actually given. However, from this endpoint to this line segment, I do have a height of 1.6. Now, this line segment, I have a height of 0.62. I have a width from this line segment to this side line segment of 0.62 as well. This width of this top line segment is 0.25. I am going to do this a little quick. Then my last dimension is from this line segment to this endpoint, and it is 0.85. So now I have in most of my dimensions. The main one that everyone forgets is the overall height. Since we are looking at the side profile, we do not see the overall height, but since we're given the front view, that overall height dimension is listed there. So I'm going to select my top line segment, my bottom line segment, and bring it over, and it is listed as 2.5, and hit OK. By adding in that overall height, I now have a fully defined part. If your part's not fully defined, make sure you are connected to the origin, that this bottom line is horizontal, this side line is vertical, this top side line is vertical as well as this one, and then your very top line is horizontal. So now I'm going to go to my Features tab, since my sketch is fully defined. I'm going to extrude it. This is where we're going to use our first global variable. So for the depth, remember to use a global variable, you have to enter the equals sign first. So I'm going to select equals. Then this drop-down menu comes up. So I'm going to go to my global variables and select my L variable. And then hit OK. So that automatically extruded that sketch to that L value of 4.96. So make sure you are using your variables in your extrudes, and remember, you have to hit equals to utilize them. Now I want to just sketch on this front plane. So go ahead and select that plane, bring it normal too. So we're looking at it perpendicularly. Go ahead and hit your sketch icon, open a new sketch, and now I'm just going to sketch a basic rectangle. This part is tricky because we are at an angle, so you can see this bottom edge down here. So if your rectangle is only sketched to the bottom edge of the face selected, you'll have this bottom lip that will still be there once you cut your hole through. So you want to make sure that your bottom rectangle is attached to the very bottom edge, so that slanted edge here. So I'm going to zoom in, I'm going to select that very bottom edge and bring up just a basic rectangle. If you have a hard time, you can also just select the bottom edge of your rectangle, hold down Control, select the bottom edge of your trimmer head, and add in a collinear relationship. So now I'm going to dimension this. So go ahead and go to your Smart Dimension tool. It gives me a height of 1.25. My width is going to be my S variable. So once again, that bottom line segment for the width, I'm going to hit equals. I'm going to go to my global variables and select S and hit OK. I also need to add in my T variable because it's the thickness between the edge and the starting edge of my cut. So select both of those line segments. Go ahead and hit OK for that variable. Select your global variable of T and hit OK. So now that sketch is all blocked, so it's fully defined. You'll also notice my dimensions. A summation sign has appeared before them. That means they are utilizing that global dimension. If you do not hit equals and you select your global variable, it will bring up the right value, but you will not see the summation sign. So it's not going to reference your equations. So when you go in and change your variables, your part won't update correctly. So if you do not see the summation sign, try your dimension again. Remember to hit equals and then select that variable. Now I'm going to go to my features since my sketch is fully defined, and I'm going to extrude cut that rectangle. I'm just going to turn it so you guys can see. The direction can remain blind since we have no material that we need to worry about behind us. My selected contour is that rectangle sketch, and OK. So now you can see I have a full sketch, a rectangle cut out. So grab this front face again, bring it normal to you, and let's create a linear pattern of that. So I'm going to select my linear pattern icon. My direction is just going to be this bottom edge. Now make sure that your arrowhead is pointing away from your first seed feature. Remember, when we are creating linear patterns, you want to create a seed feature. So that means the sketch plus the feature. So in this case, the extruded cut, and then replicate it in a pattern. Do not just create a sketch and then pattern it, because you won't be able to update the features as easily, and it will give you a lot of errors in the future. So you need to only pattern a seed feature, not a seed sketch. So I have my sketch, my feature done. So I select my pattern, the bottom edge, because I want my pattern to go away from me. That distance now, I'm going to use my global variables. So I'm going to have equals. Now this part can be a little confusing. For my global variables, I'm going to select t, and then I'm going to add another global variable of s. So you'll have equals t plus s, because when you're creating a linear pattern, you are not only replicating the rectangle you have cut out, but you need to replicate the thickness in between each of those rectangles. So t plus s is going to be this space plus our cutout, so from this edge to this edge, replicated over and over and over. So make sure your distance is equals t plus s, and you're utilizing those global variables. Now, for our number of instances, we have 8. You'll notice with the distance that a summation sign also appeared once I utilize those global variables. So make sure that happens in your feature tree manager. So I want 8 instances for my features and faces. I'm just going to highlight the area, select this over arrow, and go ahead and select that whole overall cut. You'll see I have a preview where everything looks equal, and go ahead and hit OK. So now I have all those cuts. My trimmer head is starting to look like a real trimmer head. Next, let's go ahead and we're going to fillet these edges first. So I'm going to select my fillet icon, and then I'm going to select this top edge, hold my roller on my mouse down so I can rotate my entire part, select this other top edge, and I'm going to read my drawing. It gives me that the radius of this arc is 0.25. So I'm going to hit OK once I change in that radius and hit my check mark. Now I'm going to select this front face and bring it normal to. Go to sketch, open a new sketch, and select 2 circles, or just my circle icon, but I'm going to sketch 2 circles and hit OK. Now I'm going to smart dimension just one of these circles. So this dimension is also 0.25. You can see the shorthand in the drawing says the diameter is 0.25 times 2. That means they're both the same size. So since they're both the same size, I only need dimension 1. I'm going to select its sketch. Go ahead and hit your control key on your keyboard. Select the outside sketch of my second circle, and I'm going to add in the relationship of equals and hit OK. Now I don't have to dimension both of those circles. So I still need a placement for this circle, for both of them actually. Remember, for circle you need its size plus a placement. So since my drawing does not give me a vertical and horizontal placement or values for them, I automatically know that I'm going to need a concentric relationship between this filleted edge and my circle. so it will become fully defined. So go ahead and select that edge or that arc you've already created, hold down your control key and select the edge of your circle and add in that relationship of concentric and hit OK. You'll see that our sketch is now fully defined because that gives it its placement, so the material has the same thickness all the way around. So let's go ahead and do the same thing to this side. Select your edge, hold down control, select the edge of your circle, and go ahead and hit the concentric relationship and hit OK. So without closing my sketch, I'm going to go to the Features tab and hit the Extruded Cut. This makes it easier just because now I don't have to select both those sketches. I can do one extrude per sketch since there are technically two sketches. Normally we want to have a sketch and then one feature, so a feature per one sketch. But since our circles need to be cut the same distance and they're created on the same plane, we can do one feature for them. So I'm going to leave the direction as blind. You can change it to up to surface. That would still cut through or through all, just as long as they're cut all the way through. So there is your trimmer head. I'm going to select it, go to my appearance icon, select the part. I can change it to yellow and hit OK. The last thing is we do have this note that fillet all edges to 0.03. So instead of selecting the face, which will select just the edges on that face, or selecting every edge by itself, I'm just going to click down in my part document window and highlight my whole part. It will automatically select all those edges. Then I'm going to go to the fillet icon, scroll down and change that radius to being 0.03 and hit OK. And now all those edges are filleted and I saved a ton of time because I didn't have to manually do it. If you look, you'll notice that my back edges are not filleted. So I'm just going to once again highlight the whole part, hit my fillet icon, scroll down, my radius is still 0.03 and I'm going to hit OK. I gotta make sure that some of my fillets are not being selected twice. That is one issue here. So since these edges are already filleted, I need to make sure I unselect them. So basically I just need to highlight these inner edges right here. So I'm just holding down control, selecting all of those. Go ahead and hit fillet. Make sure your radius is correct and hit OK. So now that error goes away, all my edges are now filleted correctly. So this is where the awesomeness happens. Once you have your part fully, every sketch is fully defined, your features are fully defined, and it looks correct, go ahead and go to your equations folder. Right click and go to manage equations. This is where we test all three of those values. So we know that my L value of 4.96 works. So I'm going to try it for this medium value, 3.96. And hit OK. Since I use all my global variables in my whole extrude plus my pattern feature, you can see that that part got smaller. My rectangle extrude cuts got more narrow, and I have no errors listed on my feature tree manager. Go back to your equations, right click, go to manage equations. Let's try it for 2.96, our smallest trimmer head. Hit OK. Once again, it shrunk again, no errors are coming up. My part looks great. So that is the point of this assignment. You need to utilize your global variables. You need to be able to list them in your equations. You need to be able to list them when you're creating your features as well as your sketches. Make sure that you've listed your fixed equation, your L value, and you're only changing your L. You don't need multiple L dimensions. And also that you have solved for S and you're utilizing that equation. So if your part works for all three L values, you did it correctly. If not, let me know and I can help you through it.